Yeah, all set. Over to you, Tarun.
Yes, thank you. So, hello everyone. And now, welcome to this session, which is about creating serverless applications using AWS Lambda. By now, you must be familiar with cloud computing, and you would have seen various cloud providers and their platforms. Amazon Web Service is one of them, and other providers are Google Cloud Platform as well as Azure from Microsoft. So these are some of the cloud providers which are very popular. And you must also be wondering about what is all the buzz about serverless computing. And you would have also heard the term function as a service. So serverless computing and function as a service, they all mean the same thing. And in this session, we'll cover in detail and with demo about this topic. So the agenda for this topic is how to create serverless applications using AWS Lambda. And we'll start with limitations of currently used server-based computing. Then we'll cover about what is serverless computing. We will also go through benefits of serverless computing, and we will understand a service known as AWS Lambda. So although I have shared that there are various cloud providers, like Google has Google Cloud Platform, Microsoft has Azure, but in this session, we'll focus mainly on Amazon Web Services. And in particular, there is a Lambda function or Lambda service, which provides the capability of serverless computing or function as a service. After learning about the AWS Lambda, we'll look into the application architecture and how we can create serverless applications and what could be the key components of serverless applications, and in various scenarios, how we can apply serverless computing. And then we will end with the demo where I'll show you how to create your own Lambda service and utilize the capability of serverless computing. So this will be around 40 minutes of session. And after going through this session, you will be aware about what is serverless computing, why it is important, and what are the various use cases where it can be used. And you'll also get some starting understanding of AWS Lambda. Although AWS Lambda is a very big, vast topic, but in this session, you'll get started and you would be ready to explore more. So let's begin our learning journey. Any questions about the agenda? In case you have any clarifications, you can interrupt me, you can raise your hand and I will respond to you. And we'll keep this session interactive. It's more important that you understand each and every concept. So feel free to raise your hand and then I'll take up your query. Also, you can leave the queries in the chat message. I'll be looking into the chat message at regular intervals, and after every session, I'll take up the chat messages and I will respond to the queries there. So let's begin to the topic. Are you all ready? Shall we start? Okay, great. I see everyone is ready and excited about the topic. So let's move on to introduction about serverless computing. But before we deep dive into the serverless computing, we'll learn about the limitations of server-based computing. This is since many years, and we know that server-based computing is a kind of application architecture where you have a traditional server, which are expensive and also difficult to manage. And you need to take care of a lot of things, starting from capacity planning, upgrading these servers, ensuring your servers are secure, and you have to also accommodate for increase in demands or traffic spikes, because for your application, if it is a large scale application hosted on cloud, you'll not have always consistent traffic. The traffic will be small sometimes, or it would be too much of traffic at some peak hours. So you have to plan for increased demand, and you have to keep the capacity ready in your server infrastructure to deal with this increased demand. So this is about the traditional server-based computing, which is everyone must be familiar with. You have your applications running on servers, and you have to take care of everything which is required to run these servers. And these servers are complex, they are expensive, and they are difficult to manage. So let's see, what are the limitations? What is there are more limitations. We touched upon few, and let's get into detail. So as I said, serverless computing is costly. The servers which you have to host or which you have to provision from your cloud providers, they are expensive. And they are inflexible as well. And you need to do a lot of activities around managing these servers. As I said, you have to do upgrades, you have to do security patching wherever necessary, you have to do regular maintenance activities like restarting it and ensuring you have the right amount of memory consumptions and CPU performance. And you do a lot of maintenance activity on the server. So it requires cost, and it also requires time, because setting up servers take time. You have to provision, you have to ensure that it has the most up-to-date operating system as per your requirement. You have to ensure it has all the tools and libraries required to run your application. And then you have to set up your environment and host your application, deploy your application, which is time consuming. Several times you would need a team of experts to keep your application running smoothly. And as I said, these are, there are various activities, and these activities are also difficult, and you need experts who can dedicatedly look into your servers and manage them. Even after spending this much amount of cash, or if you are putting a lot of time for your server-based computing, and even if you have experts, there's no guarantee that your application will be running as per the demand. And in the internet world, a lot of times there are increased demand, and your application needs to scale, and it has to be very responsive. So here, it sometimes do not help. Server-based computing do not help, because there's no guarantee that the servers you have provisioned are as per the right demand, and they will keep running all the time, because internet is a dynamic world, and there are various kinds of issues which come on the way. Maybe there could be some security vulnerability, there could be denial of service attacks, and you have to spend a lot of time to deal with this. So these are the four main disadvantages or limitations of server-based computing. I will summarize again. First thing is you need to provision your server, which require cost, and you have to incur a lot of expense for provisioning your server, whether you provision it in your own data. It could be on your own data center. Then you have to procure servers which are expensive, or if you have to host it in any cloud provider, then also you will need a lot of money to be spent. And even if your application is not being used by the customers currently, you will be charged for the reserved server capacity, and you have to ensure you have capacity available for your peak load. Serverless computing is the solution, and it will deal with all these problems. This we will see later in this course about how serverless computing reduces these limitations and provides additional benefits. So just ensure you remember these limitations of server-based computing. Number one is it's costly. Second, it is time consuming because it requires a lot of effort. Third thing is it is complex and difficult. You may need a team of experts to deal with server-based computing to ensure your servers are up and running. And it will require regular maintenance activities as well, like upgrades and patching, applying security hotfixes, etc. So let's move on and let's learn about serverless computing. So in a serverless computing, you have a platform provided by cloud provider. AWS Lambda is an example. And serverless computing does not mean you do not need servers. Your application still will be running on servers only, but you need not have to be thinking about your servers. You just focus on your code. So here the cloud provider manages all the servers which are used to run your applications or services. And various activities like patching, provisioning, managing the servers, upgrading the servers, it's all taken care by the cloud provider. And cloud provider will also provide you monitoring of server performance and handling the capacity of your computing resources. Your server provider or cloud provider will take care of handling the demand, handling various capacity requirements of your application based on how it is getting consumed. So in case you need more resources, they will be provisioned automatically to your application, and you need not have to think about any of these overhead. You just think about your business logic and code. So this is for most important characteristics of a serverless computing, that you do not have to think about managing and operating servers. This reduces a lot of burden from developers. And if you are a small enterprise or a startup, this is a great benefit because you just focus on doing your innovation, and all the overhead around the infrastructure will be taken care by the cloud provider. So yes, as I mentioned, developers or the application providers only need to worry about the application code. You still run your applications on servers or clusters. So do anyone have any queries around what are clusters? Clusters are collection of servers. So when you are running large scale applications, you would need more than one servers, and various servers will be sharing the same configuration. So cluster of servers are collection of servers, usually of same type, and they will be used for serving your applications. And most of the time they could be behind load balancer. And when the request comes to the application, the load balancer will redirect the request to any one of the server. So this is about serverless computing. And as I said, the cloud provider will manage all the server stuff like provisioning and configuring servers, and you just have to focus on code. So is this a very great and interesting thing? I am sure you all would be finding this really exciting. Any queries at this time? If you have any queries, feel free to drop these queries on the chat, or you can raise your hand and then I can take up the call. Okay, great. So I see no queries. I think everyone is with me and they are understanding the concept. Great, good job. So let's move on further. And now you would have understood the serverless computing very well. So important point to note here is, although you have to just worry about your code and the cloud provider manages the provisioning and configuration and upgradation or management of your servers, your application can scale. And in case you have even spiky traffic, that sometimes you are getting a lot of load on your application, and on other times you don't get too much of load. Say, for example, if you are having a site running like Book of My Show, and when there is a popular movie getting released, then suddenly you will have thousands and thousands of users reaching out to your site to book or check the details of the release. And on normal day, maybe a weekday, your traffic may not be that high. But when there is a movie released and when it's a popular movie, your application will have a lot of users requesting for shows and requesting for booking of tickets. But on usual day, when there is weekdays, the traffic will not be there. So this is called a spiky traffic. And it could be 100x or 10x or 1000x when there is peak season. But on normal day, it will be usual traffic. So if you have such type of traffic, even that can be handled by serverless computing. So your application will scale as needed in serverless computing. So this is one of the additional benefit, which is mostly very important factor, because you don't reserve your resources, you pay for what you consume. But even if you have a great demand, so then your application can still cope up with that increased demand, and even in shorter duration as well. So yes, now you would have understood why serverless computing is important. But let's revise and go through this. What exactly are the key benefits of serverless computing? So the faster time to market. This is very important benefit, as I already shared. For startups and for small enterprises, this is very important factor. Here, if you have a product, since you only have to focus on your code, you can release your product faster. So if you have a software solution, you can get that out to the market faster, because you do not have to worry about provisioning servers. You do not have to worry about what is the capacity you would need. And you do not have to worry about ensuring your applications are running on the latest versions of operating system with all the security fixes, and maintenance and all is also taken care. So this makes you more efficient, and you get faster time to market with the help of serverless computing like AWS Lambda. You also do not have to perform any server management. So you do not need a team of experts, and you only need developers and people with infrastructure understanding, or what you call now service reliability engineering is not required. So your entire service reliability engineering team may not be needed if you're running your code on serverless computing. And this also saves time, and it also saves a lot of cost, which is required to develop your application and host your application and make it available for your customers. I also shared that serverless computing is a scalable application. It provides a scalable infrastructure, and it scales automatically. So you need not have to do any configurations regarding auto scaling and how much compute to be reserved for your application. Your application scales automatically. And one other important factor is high availability. From serverless computing, you get high availability. So earlier, as I explained, that you need clusters of servers. And I also explained what are clusters, so it would be clear for you. A single server is not most of the time highly available, because you may get hardware failures, network failures, and various other situations which can lead to the disruption of your application. So high availability is very important for your application or solution if it is serving customers and you are generating a lot of business out of your service or application. And for many of the application, it is a critical requirement, because assume you are running a banking site or service for financial transactions, you would want this to be available all the time. And if your service or application goes down, you'll lose business and your customers will face a lot of inconvenience, leading to their dissatisfaction, and you may get out of the business if your application is not highly available. So ensuring high availability is a very critical factor. It's as good as performance. Your application has to be very performant, and at the same time, it should be very highly available. And the last point is you save cost, because even if you need peak load of maybe 1 million users a minute, but you need not have to always keep reserving these resources. Your application will automatically scale when there is a rise in demand. And when there is normal usage, these resources will be freed up. So with serverless computing, you get a pay for use model where you only pay for the capacity which you are using for running your applications, and you need not have to reserve or block any servers. And this leads to a lot of cost saving. So let's think about that. These benefits, are they really great benefits? And shall we move ahead to the next topic? And in case you have any further questions, we can take up at this time. So are there any questions? I'll take a pause for maybe 30 seconds to get any queries. And in case you have any queries, do let me know. Okay, so there's no query. I will go further and we'll cover other topics. What's next? So now let's dive into one such service, which is Amazon Web Service. And it's similar service like you have S3 bucket or Kinesis, and there are several services available in AWS, but one of the important service is AWS Lambda, which is about serverless computing. In serverless computing, as I already mentioned, you run code without managing servers. And AWS Lambda is a service in which you can leverage this technology of serverless computing. Not only that, it integrates well with other AWS services. So if you are using Amazon Cloud for provider and using it for storing your unstructured data in S3 bucket and using any database service like DynamoDB for storing your structured data, and you want integrating and you want integration of your code between your Lambda service and your other service where you are storing your data, that's also possible. And this is through AWS Lambda service. You can create event-based applications. So your code in AWS Lambda can handle events, which could be like upload of a file or image processing, like compression of an image or creating an image in different resolutions if you are serving it over a website or mobile applications. So you can take care of all these events and you can handle it in your code, and the code will only be triggered when these events will be triggered. So these events, whenever their events is fired, your code will be triggered and the event handler will be called. So this is how generally the code as a function as a service or serverless computing works. Other important factor is AWS Lambda is scalable and is highly available. I already talked about what is high availability. Scalability is mostly, you are all aware that when the demand increases, your application needs to be scalable, and not only it should be able to serve the requests, but it should also have acceptable performance as desired by the customers, even when there are increase in demands or users or requests for your application or services. So scalability and high availability is very important, and both of these characteristics are there in AWS Lambda service. And not only AWS Lambda service can integrate with Amazon services like S3, it can also integrate with other services which are external to Amazon. For example, Apple push notification service, which is used for iPhone users, and your applications can send notifications to your user base who are using iOS applications. So not only AWS provides external service integrations, it also provides internal service integrations as well within Amazon, and external service integration to services outside Amazon. So these are some of the key characteristics of AWS Lambda. And then as we saw, these were the benefits of serverless computing as well. Let's now get into more technology, and we'll cover what are serverless architecture. So here we'll discuss what are the components involved and how to interact in a serverless application. So assume we have created a website using serverless architecture. So this is how it will work, and this is a high-level diagram depicting various components, how they interact with each other. So here you have a client, and client is requesting your website, and you are hosting your website in Amazon S3. So you have an Amazon S3 service already, which is used for hosting your files images, HTML, CSS, and JavaScript, what all resources you need for the site. They are hosted in Amazon S3. So whenever you make a call, so you will reach out to API gateway here. So you have various services here. The one service you see here is API gateway. You have Amazon Cognito user pool. This is a service where you are storing the user profile information. So it's a user directory, and it also takes care of authentication. So your application or website is a secure application and it cannot be accessed by general public. So in that case, you'll need a directory service like Amazon Cognito. So when user requests your website, he will first get redirected to Amazon Cognito service, which provides user registration and authentication for your application. So this is how your flow will work. First, you will request a website. In case the user is not authenticated, he'll be asked by the Amazon Cognito service to authenticate. And your files such as HTML websites, JavaScript, and images will be served from Amazon S3. And whenever you have any dynamic pages you have on a website both static and dynamic content. Static content is a content which do not change. For example, if you have about page of your company, it will not change very frequently. And if you show your logo, and if you show about the portfolio and various other details about your company, that kind of content is a static content. So here this is mentioned static content and stored in Amazon S3. So this is a very efficient storage for static content. And when you have dynamic content are content which is changing. Say, for example, if you're querying for the number of seats available for a movie, this is dynamic content because as users are booking the seats, you will have the number of seats available changing. And when new movies are released, new shows will be added for a booking application. So this is dynamic content, and the way you serve this dynamic content is through Amazon API gateway. So first you will expose your resources, which is there in the database. For example, in a Book My Show application, you have seat as a resource, or availability. Seat availability is a resource. So you'll expose an API which can be used to query seats available for a show, and to host or to expose an API, you use an Amazon gateway service. So this is again another example of Amazon service, which is Amazon API gateway service, which takes care of exposing your RESTful APIs. So your website will call the RESTful APIs, which will in turn trigger a Lambda function. So whenever there is a call to this gateway and you are requesting for the resource, which is seat availability, this is an event. As I said, AWS Lambda is event-based computing. So when this event is fired, your code within the handler will be triggered, and AWS Lambda may read out the current availability from the database and respond you the result back to the user, which can be shown on the site. So this is how your serverless website will work, and it will be able to deal with both static and dynamic content. So this is one of the use cases. There are many other use cases which you should be aware of. And here is the list of various other use cases. This, just for your reference, will not go into the details of each of them because of the time limitations. But yes, I'll briefly explain them and we can take it later in case we have any further queries around it. Feel free to reach out to me after this session or whenever there is an opportunity to interact with me. And in case you have more queries around any of these topics, which we will be covering now, feel free to ask me. But yes, we'll be going through these topics really fast and will not go into details. So other use cases is, for example, if you have a service for file processing, then when you upload a photo, for example, you click a photo and then upload it to Amazon S3 photo storage. This is an event triggered for Lambda, and AWS Lambda can run the code for image resizing and can store these images in different formats suitable for mobile and tablets. So this is pretty simple use case. I'll move to the next. Next use case is stream processing. Stream processing is something like if you have social media stream, and this is coming through a service called Amazon Kinesis. So Amazon Kinesis is a streaming processing service from Amazon, which can provide you streams of, say, for example, social media streams in real time. And this is stream, when it arrives for your application, this is an event which could be handled by AWS Lambda, and it can filter out, say, hashtags and identify social trends from the stream of social media stream. And it can store the insights. For example, how many hashtags are there in last 24 hours, which are trending, and these details could be stored in Amazon DynamoDB. And this you can make available in your social media site or your feature, which is sharing the trend about social media posts. So this is another use case, which is stream processing. And third, we have already seen in detail, is web applications. And we saw both how we store static as well as dynamic content. So this is the same architecture, but represented in a different way. So I'll just kind of skip this because we have covered this in detail. And then we have IoT backends. IoT backends is another use case. Say, for example, you have a lot of devices which is monitoring maybe the moisture and soil quality of various agriculture farms. Or there could be sensors on some devices like sprinklers or tractors. Then these IoT devices on these instruments or vehicles can send messages to your stream processing service, which is Kinesis. And when the Kinesis receives these data for processing, that could be an event for Lambda. And then AWS Lambda can run your business logic and process the data and generate useful output, which could be required by our application. So for example, in this, you may have various IoT devices on various farm equipments and vehicles like tractor. And whenever there is any problem like servicing required or some part is getting out of order, then there could be a data which could be streamed to Amazon Kinesis, and this can trigger an event for AWS Lambda, and this can in turn create some output like placing an order for the spare part. And this is how you can automate business workflows in IoT scenarios as well. So your Lambda service could be a backend for an IoT service as well. On the same lines, you can use AWS Lambda to create backend services for your mobile applications. So now let's move to something more interesting. This is about the demo. So you have learned about all the benefits of serverless computing, why it's needed, because we also went through what were the limitations of server-based computing. And then we understood various use cases and architecture for using AWS Lambda in different scenarios. So let me take you to the usage example of AWS Lambda. So this is a demo time. You'll definitely enjoy it. So let me switch to my browser and we will see how AWS Lambda work, and we'll do live coding. So I'm into my AWS console and I see this is my latest, the console, and I see there is an option. You have so many services in AWS, but if you see that, few of the important services are Lambda, API Gateway, IAM. And to find Lambda, what you can do is you can choose compute. And within the compute section, you'll see Lambda service. And this says run code without thinking about servers. This is serverless computing or function as a service. So you can click on Lambda, and this way you can go and create a new Lambda service. So to create an application, what you need to do, I am inside Lambda, and then I've chosen applications if I want to create a new application. Or otherwise, I can go to my dashboard and can show me various parameters around my Lambda service. So it not only offers you the resource where you can execute the code, but it also provides monitoring of your Lambda service. So if any errors there, or if there is increase in demand, I can monitor it using this dashboard. So I have already one Lambda service created, but you can create a new function by clicking on the create function button. And then you can author from scratch a new service. Say, for example, they are asking to start with the hello world example. Then you can use various blueprints. So there are already templates available for Lambda services, and you can modify any of these templates and create an app for your requirement. So for example, if you want to create an Alexa service, you would have a template for that as well. Or if you want to create any endpoint, which is a microservice HTTP endpoint, there is a template for it. So you have templates for plenty of things here. But yes, in this, we'll create an Amazon Lambda service from scratch. So you can say the name of the service. Say, for example, I can create a service. I can call it my message. And you can choose runtime. It supports various runtimes. So you can run code in Java, specifically Java 8. You can use Node.js, Python, Ruby, and .NET. So you have almost all the popular languages available. For this example, let's choose Python. You can choose any architecture, whether it could be x86, 64, or ARM. It do not matter until unless you have any platform specific code. So once I chose the architecture and the runtime, I can create my Lambda function. So when you click on the create Lambda function, it will start creating a new Lambda function. So this is how it's creating. And now I got the Lambda function, which is, I called it my message. I'll create a simple Lambda function. And here you see the code. right? So I have a code. It says right now, hello from Lambda. Let's say we call it serverless computing, right? So this is an online editor where you can edit your code. It does syntax highlighting as well. It will show you any type in any errors. You can test your code. You can provide any input in case required, and you can run your test in this tool, online tool, all online as well. So here, let me give some event, but yes, I'm not using an event. I will just simply run the code and it will execute. So you see here, we have this code which got executed, and we should see the output. So earlier this code was saying hello from Lambda. This is what it got printed, and we need to save this code. And if I run it again, it should then update this new message. So let me try running it. So yes, see, it's still printing out your previous message. The reason being change is not deployed. So you need to update, save your changes and deploy it so that you don't lose your changes. And if it deploys successfully, if the code is valid, the deployment will be successful and you'll get a message, successfully updated the function my message. And now if I execute by clicking on the test button, I will see serverless computing as my output. So this is how you print some message. So this is a very simple example, but you can write any Python code or code in any language, and you can really do a lot of processing, and you can create advanced scalability using Lambda functions. But this I'm executing from this online tool. This is not very useful because in real world, you would like to access this using some REST API. So let's create a REST API, and we can trigger an event which will fire this Lambda service. So in this case, I'll choose API gateway because we want a HTTP REST request. So in case we have already some REST APIs, you can configure them straight away, or you can create a new service. So let's choose to create a REST API, and we can keep open because we don't want any security at the moment. And you can create this new service. And you see here, this is the service which is my message. And this is the service which is associated with your code, which we just wrote, which is for displaying a message, say serverless computing. So this is the endpoint for our application. And if I click on this, so you get this URL, which is, we are deploying it in by default configuration. You can have your AWS Lambda application in various environments. You can have environment for development or default environment. You can have an environment for production and environment for testing as well. So in this, we just got the default environment, and then this my message is the REST API, which we just created. And you see this output serverless computing is getting displayed here. I'll increase the font size so that's visible for you. And this is the desired result. So you see this Lambda function in action. So this is about the demo. So just re-summarizing the steps, which is used to create the Lambda service. We went to Lambda service by selecting the services in this top menu on the left side. And then we chose compute. And from compute, we chose Lambda. And if you're using Lambda frequently, then you'll see next time in your recently visited services. And then we created a service on API gateway, which was an endpoint called my message. You wrote the code for your API gateway. The code could be very complex, and but in this case, it's just returning a message, serverless computing. And then you can make a call using your browser, and we do not put any authentication. If you put authentication, then user needs to be authenticated, and only if user is authorized to run your service, execute your Lambda service, then only he'll see the output. But in this case, it's a public service. So you just trigger the API associated with the service. So this service API was called my message API, and I triggered this using a URL in my browser. And when you trigger this URL, it will give you the desired result. So this is all about Lambda service. And let's come back to our presentation. Hope you enjoyed this entire session, and you would now be feeling very confident about using Lambda services, and hope you understood all the intricacies like benefits of AWS Lambda services and what are the use cases where it is used. So enjoy. I would suggest everyone to play around with AWS service. I have provided you a demo. So you can create your developer account. It's totally free. And then you can start playing around with AWS Lambda service and create interesting applications using it. So do share me if you really create some interesting applications. Share me the link, and we'll talk about that in more detail. So have a nice day. Thank you. Bye.
Hi, Tarun.
Yes, hi.
Just a second.